We're going to look at some examples thinking about what we learned about Gibbs free energy. When water freezes, the phase change that occurs is exothermic. Exothermic, remember, is favorable for enthalpy. We have a change from liquid to a solid where that's delta S being negative, which is not favorable. Based on the change in enthalpy, you would expect that water would always freeze. Use the concepts of entropy and free energy to explain why this phase change is only favorable below 0 degrees Celsius. So again, delta G is based on our delta H, which in this case is negative, plus our change in temperature and delta S. Since our delta S is not favorable, it's a negative value, that means that I'm only favorable at low temperatures so that I can get both of my, or all of my terms negative. Also, if we think about what's happening here, water molecules are constrained. There's positional entropy, which is being reduced. It's favored by enthalpy, but disfavored by entropy. As our temperature decreases, our entropy contributes less to delta G. Again, so as temperature decreases, entropy will contribute less to delta G. In this reaction here, in this example here, we're going to do a mathematical calculation of Gibbs free energy. For a reaction occurring at 25 degrees Celsius, the value of enthalpy is determined to be 10.5 kilojoules. So I know that that's endothermic. The delta S is 30 joules per Kelvin. Is this reaction spontaneous at this temperature? We need to do two things right away. First, we need to convert this into Kelvin. And since our delta S is given to us in joules, we need to convert our enthalpy into joules. So Kelvin is equal to 25 degrees Celsius plus 273 Kelvin. That gives us 298 Kelvin. Our delta H is equal to 10.5 kilojoules. For every 1 kilojoule, I have 1,000 joules. That gives us 10,500 joules. Now I can calculate my delta G, which is equal to 10,500 joules minus 298 Kelvin times 30 joules per Kelvin. I can see here my Kelvins canceling out. I will follow my numbers to get 10,500 joules minus 8,940 joules. And finally, I'll get 1,560 joules. Since this is a positive number, my reaction is not spontaneous. Not spawn. Okay, also, I have 1 sig dig here, so my answer would have to be changed to 2 times 10 to the 3 joules.